Okay, good morning, everyone. Any questions? Good morning, Esmeralda. Any questions? Okay, so we get started. Okay, I'm going to ask you a few questions from the homework just to get going, and then we start solving equations. So it's problem number 1 that I've assigned for you. So it's problem number 2. I want quick answers because that should be quick. So ln, the question is, do not use your calculator at all and calculate these numbers basically without using a calculator. ln of e squared equal. Please, I want quick answers, get you going. ln of e equal.
ln e squared would be 2.
Because
well, the property we have is the ln e n would equal n because e to the nth power would be e to the nth power.
Right, because the definition
so e to the
of
second power equals e to the second power.
Right, because the definition of the ln is what? It's the power of e that gives you what's inside.
Power of e that gives n.
Yeah, and what's playing the role of n in my problem?
2.
No.
Oh, e is playing the role of n.
Right, what's playing the role of n is the input, this. Right, but that's what playing the role of n, which is the e squared. So the question is, which power of e gives you the e squared? I mean, it's 2 itself. Okay. All right, log ln of e. Please, all of you, quickly.
1.
1. Again, for the same reason. What's the power of e? That gives me e. The power of e is 1. Right? ln of 1. Please don't use it. I mean, you guys can pick and use your calculator. I don't see you, but please don't try to interact. ln of 1 quickly. 0. Math, because
it would be e and then whatever squared equals 1.
Right.
Addition.
So the interrogation mark should be the interrogation mark should be 0 because e to the power 0, sorry, nonsense. Because e to the power 0 will give me a 1. All right, ln of 1 over e squared. Okay, ln of 1 over e squared. It's the same principle. Basically asking yourself, e to which power will give you 1 over e squared. Anybody?
Since it's a fraction, it'd be ln 1 minus ln b.
Oh, that's one way you can do it. That's one way you can do it. I will comment on this one more, but that's one way you can do it. But another way, e to which power will give you 1 over e squared? And I will get back to what you said, which is correct. Remember negative exponent. E is a number. Do not never be afraid of it. That's 1 over e squared is e to which power if I want to use negative exponent?
Oh, you'd use -2.
-2. So it means the interrogation mark I want is -2. So this is -2. Okay. Now I go back to to comment that your classmate did. He told me or, which is absolutely correct. ln of that is ln of 1 minus ln of e squared. That's another way we can do it. ln of 1 is 0 minus ln of e squared, it's a 2, which is equal to minus 2. Absolutely the same answer. So you can do it both ways, either using this property or going over the definition of the ln. Right? So what is ln? By now, this should be much easier. 1 over e to the power 3. Please, all of you, pitch in. And whatever the answer is, you have to give me a reason. Okay, Esmeralda tells me -3 because. Esmeralda, can you talk?
Wouldn't it be the same as the one up on top?
Yeah, which reason you want to use, this one or that one? You have a choice.
Okay, so the 1 over a to the third power.
Yeah, this
equals
is
e to the -3.
Right. So the power is -3. Okay, because that's the ln. What's as I said several times by now, the difficulty is of the ln is that we're looking to the ln of something is the power of e, which give you the something back. That's what's make it difficult because the output is a power. The output is a power. All right, so now let us see. I will pick 2 more. ln of the square root of e. I'm basically doing number 2 from the book. You can ask yourself the same question. The ln is, there are 2 ways of doing this problem. The definition is, you're looking for ln, that's your n. The ln is this power. A half, absolutely, because square root of e is e to the power a half. So this gives me that my interrogation should be a half. ln is a half. Okay. All right, now ln of cubic root of e squared. This is h in the book. Again, the cubic root of e squared. So basically, I'm looking for the power of e that give me the cubic root of e squared. So basically, the question is cubic root of e squared is e to which power? It's e to the power 2/3. Remember when we introduced the fractional exponent, the 3 is the denominator, the power is the numerator. So this is going to be equal to 2/3. Okay, finally, ln of 1 over the square root of e equal. You can do it any way you want. Okay, anybody? Anywhere you want, we can do that. Okay, Taylor, why it's -1/2? Can you talk? Do you have the microphone?
When it's a negative, you do the 1 over.
Go, tell me what to do. Tell me, I'll follow you. So 1 over square root of e. Okay, it means 1 over e. Square root of e is e to the power a half. Okay, now e to the power a half, if I want to bring this down, it becomes e to the minus a half. So this is the power. That's the question mark I am after. So this is minus a half. Okay. Questions? So today we're going to go back to, so this is as a preliminary to just keep reminding you the definition of ln, because it's not an easy definition, we have to keep at it. Now what we're going to do is we're going to go back and solve equation involving the, when the unknown is a power. So we started a little bit last time, so I'm going to review what we did last time, and then we're going to do more today, a lot more today. So as I move on, you guys will help me out. So solve the following equation. I forgot what I gave last time. So 2 to 2x equal to 7. And we have to solve for x. So x is the unknown. Is the unknown. And this is 4 to the power 2x. All right. How do we solve an equation where the unknown is a power? So it's right there. It's very, very, very problematic. I mean, very problematic. How can we do it? All right. I will do the first one by myself. The first step usually is to try to isolate the exponential term. It means a term that's 4 to a power. So the step number 1 is we need to isolate the exponential term. Now, if we isolate the exponential term, what do I mean? If I want to isolate 4 to the dx, so I do that by dividing by 3. So we divide by 3. So it's going to give me 4 It's going to give me 4 to the power 2x equal 7 over 3. So the first step is to isolate the exponential. To do it, we have to divide by 3 both sides. Once I do that, I need a way to bring the 2x down. That's really my goal, is I want this 2x to become down. So the way we do that is we take the natural log from both sides. So it means that I say, all right, if those are equal, it means ln of the first is ln of the second term. Now, what's the benefit of doing this? What's the benefit? Do you guys have any recollection? What's the benefit? Anyone? We had a benefit. Why did we take the ln from both sides?
One would be able to take the 2x and move it in front of the 4.
Right, because which property of ln we're going to be using?
I forgot the specific one.
Which one? ln of a to the power n is equal to what? Do you remember it? It's n times the ln of a. That's the property that's going to be very useful. So the idea now is that this 2x can be brought down. And I will have the 2x multiplied, we're multiplying it by the ln of 4. Now be very careful. The power here is the 2x. It's this whole expression that I'm going to bring it down. This is equal to ln of 7 over 3. Okay, and that's the 2x. That's an x here. So now how can I solve for x? The benefit is to bring the x down. How shall I solve for x, do you think? I'm going to isolate my x. How can I isolate my x now? Back to you. I'm asking you to solve this equation, if I ask you to solve 6x equal 5, forget about ln, how would you do? Are you guys with me? Okay, I will pick.
You would divide 6.
Yeah.
We divide both by 6, and then you get 5, 6. How do you want me to do that here?
You divide by ln over 4.
Okay, we divide by ln of 4. What will I have?
Just the 2x left.
Right, I will have the 2x left. It's 2x, not x yet, right?
Mm-hmm.
So how can I get the x?
Divide by 2.
We can divide by 2 again. Okay, now how can we do those two in the same step? So everything you said is correct.
Divide by 2 times ln 4.
What? We can divide by 2 times ln of 4 at once. So this is what x is multiplied by. So instead of dividing by only ln of 4, I divide by 2 times ln of 4. And then I plug in things into my calculator because x is multiplied by that. So I'm divide by 2 ln of 4. This way I can get x immediately. Or what you said is correct, but then it will give you 2x, and then you have to divide by 2 again. So you can do it both ways. Now finally, what's going to be x? Let us evaluate it. You guys evaluate it, tell me what you got, and I will evaluate it because I want to make sure you can input that correctly into your calculator. So please evaluate and give me the answer. All of you are responsible. Okay, see how much you guys are getting. Quickly, guys, there are a lot you have to talk about. Please move a bit faster. Okay, anybody got the same thing as Xavier? I want another one, so to make sure you guys gotten it correct. Anybody else? So he's getting 0.3055. Anybody got anything close to that?
Are we supposed to multiply the 2 and then the ln 4?
Here?
Yes.
Yeah, exactly. Yeah. So how can you input this into your calculator? That's why I want you guys to do it by yourselves. So in case you do a mistake, we know. So you can do it's ln of 7 over 3 divided by this whole expression. Okay, so you can do it 2 ways. One way you can do it is like this. I will show you 2 ways. One way is the following. Watch what I'm doing. I pick my calculator, I input ln of 7 over 3. I think that's the best way. Divided by, watch what I did. I open my parentheses. Within my parentheses, I put 2 times ln of 4 close to parentheses. By doing this, what am I dividing by? 2 times. So by opening the parentheses, the denominator, I'm telling my calculator that I want you to divide by 2 times the ln of 4. If I don't put parentheses here, the calculator doesn't know what I am doing. And now I hit 0.3055. Does this answer your question?
Yes, thank you.
Okay, that's the best way. That's the best way, the most accurate way of getting your answer into your calculator. So that's how we do it. ln of 7 over 3 divided by, open your parentheses, 2 times ln of 4, close your parentheses, and then you get the exact same answer. All right. Let's do another problem. We're going to do a lot of solving, some with story and some without story. But first, let us get how to solve them without a story problem. So question number 2 is the following. I want you to solve the following equation. 4 to the power 2x plus 3, so watch my power, equal to 7. Okay, I want you to solve this equation. And okay, get going. You have like 2 minutes to do it. You guys give me your answer, please. I want all of you to give it your best shot. Please, each one of you is responsible. Anyone? Okay, let's pick one of you and see what you are doing. And then I'll move on. Okay. Jake. Okay, Taylor, what are you doing?
I'm still working on it.
Okay, tell me what you're doing though, because it helps me out to see what you guys are doing.
ln parentheses 4 2x plus 3 parentheses equals ln of 7.
Okay. Step number 2, keep going. So she took the ln from both sides. Step number 2, Taylor, keep going.
You move the 2x plus 3, and then you put it.
Yeah.
Then you make it times ln of 4 equals ln of 7.
Very good. Then proceed.
That's as far as I am right now.
Okay, anybody can pitch in. So far, very good. Now we have to solve for x. What do you guys want me to do? Remember, somehow I want to get this x out of the picture. Somehow I want to isolate my x. So now I don't have x as a power anymore. Somehow divide by ln of 4. So watch what your classmates say. Divide by ln of 4. And the reason is to try to basically to free the x the best we can. So we're going to divide by ln of 4. The goal is to free the x. So this will give me 2x plus 3 equal ln of 7 over ln of 4. Okay? Are you guys with me? So now we're freeing the x. We're freeing the x. So now I can start working with the x a little bit. All right, so this is, give me what? What do you want me to do after that? So ln of 7 over ln of 4, to make the problem actually easy for us, I can evaluate it. I mean, this is for me a number. It's not really something mysterious anymore. This is a number that I can pick up from a calculator. So let me substitute this by a number, so to make it less mysterious. So we don't have this ln of 7 over ln of 4 kind of bothering us. So I'm going to put ln of 7 divided by ln of 4, and I'm going to keep the answer up to 3 decimal. So 1 point, sorry. Okay, so 1.4036. We're going to round it up to 1.404. So we have as accurate as possible. 404. Now I have a simple problem because this is a number, so it's not really a mystery anymore. Now, how do I finish solving that? Subtract 3. It means it would give me 2x equal. So now I will have 1.404. I'm going to take away the 3, which is going to give me minus 1.596. Then finally, I'll isolate my x. I get 1.596 divided by 2. And this would give me minus 0.798. And that would be my solution. Okay, so let's go through it one more time. The first step was absolutely correct, but then we're stuck. You know, the idea is I want to free the x a little bit. So we divided by 4 both sides, by ln of 4, in an attempt to free the x. Now, ln of sum of ln of 4, it's just a number that you can actually evaluate. So we did that. And then I ended up with a fairly simple equation in x. I took away 3 from both sides, and then I divided by 2 and off the problem. Okay, please questions as I move on. Okay, so now let us take, as I said, we're going to solve a lot of equations. Now let me take the following type of equation. I want you to solve the following. An equation along the same line, but it's going to involve e. So I want you to solve that. 3 times e, the number e, to the 0.03t equal, let us say, to 4. Okay, so again here, the same issue. My unknown is the power, is in a power, and I need to solve it. So somehow I need to find a way to bring the t down. So how do you want me to start? How shall I start? ln of e and ln of 4. All right. Let me see what your classmate, what do you mean by ln of e and ln of 4? Esmeralda, speak up.
I was saying like kind of like the last problem.
Uh-huh.
We would do it so we could get the 0.03t on the side.
So what do you want me to do? What do you want me to do?
So you would put ln parentheses e to the e.03t
Uh-huh.
equals ln 4. Oh, and then I forgot about the 3.
So what do you want me to do then?
I would keep it on the left side.
It's not clear to me what you want me to do. Please, everybody put in. I cannot just, I have to do something with the 3. Okay, so the easy way to think is to isolate this exponential term, as Taylor is saying. What do I mean by isolated? What shall I do to isolate it? Because I have a 3, I cannot get rid of it. But what can I do with it? We're going to isolate the exponential. Isolate the exponential term by dividing by 3. Okay, are you with me, Esmeralda? And now I will have that equal 4/3. Now I have my exponential by itself. Now I take the ln, and I am safer. So the ln of this equal the ln of the right equal the ln of the left. So this is e, the 0.03t, and this is ln of 4/3. So that's the 4/3 is inside the parentheses. All right, now keep going. What's the ln of e to the 0.03t? Back to you. That's the power here. Please put your answers. What's ln of e to the 0.03t? So here, this is ln of 4/3, which is really a number that we can pull it up. But what is this? The whole idea is to bring this term up. What's ln of e to the 0.03t? So it's 0.03t, okay, times the ln of e. That's correct. But the ln of e is equal to what? What's the ln of e? What is the ln of e?
Isn't it 1?
That's the 1. That's absolutely the 1. Okay, so it means now we have 0.03t equal ln of 4/3. Okay, now I need to solve for t, means I need to divide by this term to isolate my t. So I will have t equal, the numerator is that we can pull it into, we can evaluate it in a second. The denominator is 0.03. And the last step is plug in numbers into our calculator. So I'm going to do that. It's ln of 4/3. That's the numerator. I divide this by 0.03. And I'm getting t equal 9.5894. Okay, I gave you the answer to 4 decimal places. Now, how can you check that your answer is correct? Okay, you get an answer. How do you know that your answer is correct? Or it makes sense? How can we check? It's nice sometimes to be able to check that my answer is correct. Okay. We are solving this equation. Means we are looking for the t's that satisfy this equation. So if to check, I plug t back into here. Exactly, I plug t back into here. So it means I take 3 times e to this messed up power, 0.03 times 9.5894. I just really plug it into here. And I should get 4. If I don't get 4, it means I'm doing something wrong. So let us compute that. It's 3 times e to the power. Okay, I'm going to evaluate the power and then I multiply. So the power is going to be, so it's 0.03 times this number, 9.5894. So that's really my power here. So this is e to the power 0.287682. And now I just evaluate. Then I have 3 times e to this power, which is this one. And then I get 3.9999, 3.9999, which is almost equal to 4. So I get 3.99 now, which is almost 4 because there is a rounding error. So my answer is absolutely a correct answer. Okay. All right, one more last problem, and then we're going to make a little bit of story problem that to say why those ideas are useful. So, but this is a little bit of algebra practice. Suppose I give you the following. Solve 4 times e to the 2t plus 1. I'll make it a little bit harder, but not much harder. Equals 16. Okay, it looked like a mess, but how can I solve this? Well, how would you start a problem like that? Exactly. First, we want to isolate the exponential. So we're going to subtract 6. Both sides. So my goal is to isolate. So this will give me 4 times e to the 2t plus 1 is equal 10. Very good. Then We isolate our 4. So divide by 4. So just give me E to the 2t plus 1 is 10 over 4. Or if you want, 10 over 4 is the same thing as 5 halves, but you can keep it. That is equal to 5 halves. I totally isolated my exponential term. Now I can proceed verbatim like we did before. Now we take the ln from both sides. Then I will have ln of E equal ln of 5 halves. Now 5 halves is, this is an easy number, so I can substitute it by 2.5 because that's fairly simple. It doesn't have to be, is equal to this. And now verbatim what I did before. This is my power here, 2t plus 1. So this is going to give me the 2t plus 1 times ln of E, which is 1, but I'm going to write it here just to remind you, equal ln of 2.5. But ln of E is 1. So I will have 2t plus 1 equal this term. And now the rest is easy because now I have a simple equation in t. ln of 2.5 is a number. We should not be scared of it. And then we're going to solve for t. So what do you want me to do right now? How do you want me to solve for t? Take away 1. Now our calculator will give us a number, but before we do that, and then finally divide the whole thing by 2. And the rest is actually just plug into our calculator and we get. So let me plug that into my calculator and we'll do it in front of you to see. So my numerator is ln of 2.5 minus 1. That's my numerator. I got it. And then I'm going to divide this by 2, which gives me minus 0.0. So minus 0.0418. So minus 0.0418. I will give it to you to 4 decimal places or 5 decimal places. That's my t. Okay. So the main idea is first, whenever you have this equation that involves exponential, we isolate the exponential and then we take the logarithm and we do a little bit of algebra. Okay, so now let us take very simple story problems that where this exponential actually start playing a role. I mean, we do them for a reason. And let's start with some problems. So problem number 1 is the following. Suppose I tell you that Joe invest $5,000 in a bank, invest $5,000 in an account that pays an interest of 2% per year, which is more than you get those days. Okay, so Joe invests $5,000 in an account that pay an interest of 2% per year. So every year he gets 2% on his money, and let us say he purchased a CD that's going to last a while. The question is, how long does it take for the money to grow to 6,000? For the money to grow to $6,000. Okay, so this is, we have an account. Joe put his money, he put 5,000 and he get an interest of 2%. The money is growing exponentially because it's by the same percent. And the question is, at some point, the money is going to hit 6,000. And the question is, when will this happen? How shall I solve this problem? How can I do that? Any ideas? So you put that much, your money grow, at some point you hit 6,000. The question is, how long does it take for this to be accomplished? How would I do this? Okay. I'll get you started a little bit. We're going to introduce a function f of t. And we're going to say let f of t be the amount of money in the bank after t years. Okay, so we're going to find a formula for the money in the bank after t years. So to be able to find that, I want to find, okay, is there a rule? Do we know a rule that if you give you time, it gives you the amount of money? Now, do we know what f of t is? Do we have a formula for f of t? Yes or no? We're starting with 5,000. The money is growing by 2% per year. So what is the formula for f of t? Anyone? Okay. Jake, what do you think the formula would be?
Well, it's going to be f of t equals 5,000. Then I still need to figure out the growth rate.
Yeah, what's the growth rate?
Like 0.02 something.
That's the rate. What's the growth factor? Be careful. So it's 5,000 times b to the t. Right? What's the b?
Isn't it 1 plus the growth rate?
It's 1 plus the growth rate. Okay.
So it'd be
the growth-
1.02.
Exactly. It will be 1.0. So be very careful. It's 2% is 0.02. Yeah, no problem. Okay. So the growth rate is 0.02. So the growth factor is 1 plus that. It's 102% of the year before. So now I have a formula for my function. So this is my f of t. So it's 5,000 times 1.02 to the power t. Okay, so step number 1, we have to find a formula for how is money growing in the bank. So for every time t, that's the formula that's going to give me the money in the bank. Now, what do I need to do? Jake, stay with me. What do you think I need to do now? I want to know when the money will grow to 6,000. What should I do?
I've got no clue.
Anybody else? That's why I'm addressing those problems, because they're not very hard if you think a little bit. Exactly. So we're going to find the time now, because the question is, this money is growing. And the question now, I need to find when, when this amount will be 6,000. Means I want to find the time when this amount will be 6,000. So that's really what the question is. So we're going to find t such that f of t equal to 6,000. All right, so we're going to set f of t equals 6,000 and proceed. So we're going to set 5,000 equals 6,000 and solve for t. I stop. Are you guys with me? Are you guys with me? That's really one of the really good application of the logarithm or what we're doing. All right, so now how do I solve for t? That's a typical problem like I did before. First, we have to isolate the exponential term. So now we're going to divide by 5,000. Divide by 5,000. I will have 1.02 to the power t equal 6,000 over 5,000. Now, 6,000 over 5,000, if you guys This is not a bad number. That's not a bad number. That's gonna give me like 1.25, I imagine. This is a simple number to evaluate. So it's basically 6/5, which is 1.2, right? And now I take the log from both sides. And then I will have ln to the power t equal ln of 1.2. And now I need to solve for t. So again, this is my power. The reason we used ln to bring the power down. So it means t times the ln of 1.02 is the ln of 1.2. Be careful, we are multiplying here. That's a number, and that's a number. So finally, I will find my t. So my t equal ln of 1.2 divided by ln of 1.0. And this would give me the time, how long it will take for the money to grow to that much. So ln of 1.2, I'm evaluating this, divided by ln of 1.02. So I don't know how much you're getting. I'm getting 9.206. It means, and that's in years. It means if you put the money in the bank at 2% every year, so you get 5,000. After 1 year, you get 2% over the 5,000. So the money will grow a little bit. And then you get 2% of the new amount. So the money keeps growing. The money will grow to 6,000 after 9 years. So it's going to take 9 years for your money to grow by $1,000. And the reason it takes so long, because the rate is very low. It's a 2% rate. So it's going to take a lot of time for the money to grow that much. Okay, we're going to do another problems along the same line. And this time, I hope you guys can do it faster. So suppose I say population, for example, number 2. The population is, let us say, 4 million at t equal to 0. And it's decreasing at the rate of, so it's decreasing at the rate of 0.9% per year. Okay, so it starts at 4 million. 4 million. So the unit is going to be a million. We're not going to write 4 with a bunch of zeros. I keep 4 because the unit is million. So this is population in million. So 4 is 4 million. And the population is decreasing at the rate of 0.9% per year. Question is, when will the population reach? When will the population reaches, let us say, 3.5 million? Okay, so that's the population. At some point, the population, because it's decreasing, is going to be 3.5. The question is how long it takes. Okay. All right. How shall I start? That should be my starting point. Anybody? Don't make me pick anyone. I would rather you guys pitch in. How would I start? 0, what do you mean, Taylor? Taylor, you put 0. I don't know what 0 means. Sorry, okay. So what do you want me to start? It means the concept. How are we going to start? First, we need to find a formula for the population. So we're going to call P of T, the population, even though they don't tell us to do it, but we should be able to start this way. So the population at time T. Very good. Now, what's P of t? At t equal to 0, it's 4 times b to the t. Now we're going to find the b. All right, what's the rate? The growth rate now, the growth rate is decreasing. It means we have a negative growth rate. So it's negative 0.9%. It means it's minus 0.9 over 100. So there is a 0.9 in here. And now if we pick up our calculator and we divide 0.9 by that, we get minus 0.009. But that's the rate. That's the rate. The b is 1 minus that. Then we take away that, and that we're going to get minus 0.991. So the formula for the population is going to be now 4 times 0.991 to the power t. That's the rule. So that's really the formula for the population. And now, as Ricky said, now we're going to set the population equal 3.5 and proceed. So now we're going to, once I find the formula for the population, I'm going to set this equal 3.5 and then solve for t. So step number 1, find the formula. Step number 2, we set equal 3.5. And now we're back to what we've done the whole hour today. Divide by 4 across by 4. And this gives me 0.991 to the power t equal 3.5 divided by 4. Now, is this a nice number? I think 3.5 divided by 4 is not a bad number. I divided them, and this is gonna give me 0.991 t is 0.875. Now I take the log from both sides because I need to bring my t down. I isolated my exponential fully, and then I can take the ln down. So this is going to give me the log of equal the natural log of 0.875. Now I bring my t down, and I have ln of 0.991 equal the ln of 0.875. I need to find the t. So I need to find the time. So t equal, I divide those. So represent time. How long is going to take for the population to drop by 500,000? And now the rest is just plugging things in the calculator. 0.875 divided by ln of 0.991. And finally, I get it's going to take for the population 14 years and a little bit over and 3/4 to hit the 3.5. Okay, so that's how long it will take the population to drop down to 3.5 million. Okay, questions? All right. Now, whenever we talk about exponential, that is the simple idea of doubling time or doubling life, or which is the following. Let's say doubling time. Okay, doubling time is a fairly simple idea. If a function is increasing, let us say it's an exponential function, it's increasing. Okay, so let us say this is a. So that's the initial value. At some point, the population will double. So at some point, the population, because it's increasing, means the function is actually double. It becomes twice as much. So this is, as I said, this is 100, it becomes 200. The doubling time is how long it takes for the population to double. So it's not a hard concept. So doubling time is, it represents the time period needed for the population to double its value. The time period needed for an exponential function to double its value. To double its value. Okay, so doubling time represents the time period needed for a population to double its value. So let me I would like to do 2 examples here. Example number 1 is the following. Suppose a population in a certain town, but the population has to increase, because if it doesn't increase, it cannot double. So suppose the population in a certain town is given by P of t equal, I give you the formula, 100, and assume the answer is in million. So times 1.145 to the power t. Okay, so that's a population that's growing. And what's the growth rate? Can anybody tell me the growth rate of this population? This is the formula. What's the growth rate?
114.5%.
That's the growth factor.
Oh,
Yeah, I know. It's not confusing. What's the growth rate? It's the leftover from the 100. That's the growth rate. Okay, what's the difference? This tells me every year it grows by 14.5%. It doesn't grow by 114%. It grows by 14.5%. It means if it starts at 100, after 1 year, the growth rate, it grew by 14.5% of 100. That's what the growth rate, by how much it grew, 2%, 3%, 14.5% means it grew by, so it's growing at a very, very fast rate. It's growing by 14.5% every year. That's the growth, by how much it's growing, by what percent it is growing. It's growing by 14.5%. All right, question is find the doubling time. What do we have to do? Okay, read the definition and tell me what do I need to do. So my population is started by 100 million and it's growing at the rate of 14.5%. Every year, it's 14.5% more than the year before. Find the doubling time, what do I need to do? Read the definition and tell me what to do.
Set A equal to 200?
Exactly. Exactly. We're going to set the population equal to 200. Where is the 200 coming from? That's how long it took to double. That's what I need to do. That's why I told you it's simple. So set P of t equal to 200 and solve for t. Okay. So it means, again, we're doing the same problem. That's why we practice solving those equations and harder ones. We're going to set this equal to 100 and solve for t. So we have to, again, we're going to divide by 100. We get it 2. We take the ln from both sides. Now, again, the goal is to bring this t down. So we're going to bring the t down. Equal ln of 2. Remember, this is a number. Now we divide by it. And then we evaluate. So the last piece is the evaluation part. So ln of 2 divided by ln of 1.145. And I'm getting, it takes 5 years for the population to double. Okay, that's years. Now, it's not a lot of time. Why? I mean, let us say the population start 100 million. After 5 years, it's 200 million. Why is going very fast? Why is after 5 years it doubled? What's causing this, do you think? What do you think causing this? How is the population growing? At which rate? Every year it's growing at the rate of 14.5%. This is a very, very fast growth. So if a population is growing at this rate, it means the population is growing extremely fast. That's why it didn't take too long for the population to double, because the growth is very fast. I mean, the population is growing by 14%. That's a nightmare scenario. That's more than, that's an animal population growth than it is a human population growth. Okay, so that's really why it's after 5 years, it's going to 200, which is very fast. And this is because the rate is very high. 14% growth is a very high growth for a population. Yeah. Example number 2, along the same line, a little bit more abstract. And the goal of this example is to tell you that what the doubling time depends on is the growth rate. It doesn't depend on how much you start with. In other words, the second problem, I'm going to emphasize this idea. If I had started with 50, with the same growth rate, the time it needs to double to 100 is going to be also 5.09. So the second problem emphasizes the idea that regardless what you start with, the doubling time is the same as long as the growth rate is the same. So it's the growth rate that actually decide the doubling time. So I will give you a problem to emphasize this idea. So suppose I tell you the following. Okay. Joe invest his money in a bank. His money in a bank that pays an interest of 4% per year. Pays an interest of 4% per year. Okay. My question is, find the doubling time. It means how long it takes for his money to double. Okay, so Joe invests his money in a bank, and the bank is paying 4% per year. And the question is, how long does it take for his money to double? How shall I deal with this problem? I want you to read it, tell me the issue with it, and then we proceed. So this is the graph. It's growing by the same percent. That's an exponential growth. So it's going somewhere, and the money is growing. So this is the time, and this is the amount of money. That's the output. All right, back to you. How shall I solve this problem? Oh, I don't know what you're doing. 100% divided by 25 years. What's the logic behind that? How do you think we're going to do it? What's missing in the picture versus the problem I did a minute ago? What's missing? In this problem, the initial value, and then I will address Ricky's issues because it's a very subtle issue. I will have to address it later on. But for now, let us see what's missing in this problem. I did not give you the initial amount. And the goal is that we do not need the initial amount. So let's see how we're going to do this problem without the initial amount. This is, I'm going to call A the initial amount because I don't know it. And I will not need it, as you will see in a second. So we're going to call A B the initial amount. I don't have it, so B the initial amount. And I'm going to introduce a function f of t to be the amount of money in the bank after t years. So that's my function. So the problem is missing the A, but it's not going to affect the problem at all because I'm not asking you for the formula, I'm asking you for the double time. All right, what's the formula for f of t? It's the initial amount that I really don't know times b to the t. But do I know b in this problem? The interest is 4%. It means my b is 1 plus the 4%. So my b is 1.04. So this tells me that my function is a, which is the initial that I don't know, but I keep repeating, I will not need it, times 0.04 to the power t. And now the question is to find the doubling time. So it means I need to find how long it takes for the population to grow to twice what it started with. So now I need to find t such that f of t is equal to what? And I stop myself. I want you to finish my sentence. I want to find the time for the population to double. Means I want to find the time such that f of t equal to what? Yeah, don't be afraid. It's twice what it started with. Absolutely correct. If it starts at 100, I want to find the t such that that's twice 100. If it starts at 2000, I want to find the t such that this is 4000. Now, I did not give you at the a. It means I want to find the t such that this is equal twice times a times a. Now, how can I solve this problem? Don't let A get in the way at all, because you will see why we don't need it in a second. So how would I solve such a problem usually? Back to you. That's a problem that involves an exponential. How would I solve it? Divide by A. Exactly. I'm going to divide by A both sides. I will have 2A over A. But then what will happen with the A? My A just disappears. And I will have, this is equal to 2. So I realized that I didn't really need the A. So regardless what the A is, I actually, because the way when we set it up, my A simplified, then I will have this is equal to 2. Now I can solve the problem. I'm not really worried anymore. Okay, so I really didn't need the initial value. And this tells me that the doubling time does not depend on the initial. It actually depends on the 4, on the rate. How fast is the money moving? Now I proceed verbatim like I did before. Now we take the ln per side. And I will get ln to the power t equal ln of 2. And then I solve for my t. And then my t would be ln of 2 over ln of 1.04. And then I will evaluate that and tells me how long the doubling time is. So this tells me that ln of 2 divided by the ln of 1.04. Sorry, I did a mistake myself. So ln of 2 divided by, unless you guys are faster than me, tell me what the answer is. Anybody did it? So I'm getting 17.67 years. Okay. All right. So we're getting, it takes 17 years for the money to double. So regardless what we start. So if Joe had started with $10, after 17 years, you will have $20, considering the same percent rate keeps going at 4%. And if Joe had started with 1 million, after 17 years, he will have 2 million. So the doubling time doesn't really depends on the initial values. It only depends on actually, as you realize, on the rate. Okay, so the more rate you have, the higher the rate, of course, the less the doubling time is. But the initial value does not really depend on it. So we need 17 years to be able to figure out for his money to double in the bank. The last idea is, if we talk about, doubling time, what if a function decreases? What shall we talk about? If a function decreases, can we talk about doubling time? Yes or no? If a function is decreasing, can we talk about doubling time? What shall we talk about?
Half?
Half. Don't be afraid, half, because we cannot double with decreasing. So what we talk about, usually people talk about the half-life. Okay, so half-life. It's exactly the same. It's the same principle. So, but it's called the half-life. It's not called the doubling time. So what's the half-life? The half-life is basically, so if an exponential function decreases, it has to decrease because we cannot have it. Then the half-life is the time period needed for the exponential function to decrease to half its value. Is the time period needed for an exponential function to decrease or to half its value. To half its value. Okay, so it's exactly like the idea of the doubling time, but instead of really asking ourselves how long it takes to double, we ask ourselves, what is the half-life? It means how long it takes for the population or whatever is decreasing exponentially to be reduced to half its value. So the type of problems we expect are exactly the type of problem I did for the double time, except, so if I tell you, for example, very quick before we stop. So suppose I tell you whatever, a certain population is governed by the following equation. So definitely I want to make it to be decreasing. So I want the b to be less than 1. Suppose p of t, find the half-life. What problem? Find the half-life. Which equation I need to set to find the half-life? Back to you.
Set it equal to 5?
Set it equal to 5. Because here, the initial value is at 10. And I'm going decreasing because this is b is less than 1. My exponential is decreasing. And I want to ask myself is how long it takes to be half of it. So we're going to set the population equal to 5 and then solve for t. which is verbatim what I've been doing over and over and over, but it's just the half-life than it is a doubling time. And the half-life play a role. It plays a role usually. One of the things you can have application to that is that when they discover a body, who's dead like thousands of years ago, they use the idea of a half-life to determine the age of the body. So I think that is a problem that I will assign for next time, that you guys will have to deal with a situation like that. All right. Okay. Next week, as you guys already know, it's the last week of the class. And your final exam is a comprehensive final. And if I'm reading the schedule correctly, it's going to be a Thursday, it's the week of the final, which is, put it Thursday, May 6th. Okay. All right. So what about next week? I still have one important idea I would like to talk about for next week. So next week we have one more idea which deals with exponentials that I will talk about. So that would be on Tuesday. So basically I will wrap up the course once I get this idea down very well for you. And on Thursday, and if I finish with it, I start reviewing. If I don't, I won't. On Thursday, we will do a review. Okay.
Quick
Now,
question.
What?
Is the final exam going to be everything we've talked about since the last exam, or everything?
No, it will be comprehensive. No way out. You have to review everything. All right. So you will guys have a review. And my review for the final, it's going to be basically the review 1, review 2, and the new material combined. So that will be my review. So I usually give you the same problems, but I add the new stuff. All right. So you got the review will be out by the weekend, out very soon. I mean, most probably by Saturday, you guys will have the review. And for those who want to start, exam 1 is a review, exam 2 is a review. I mean, everything you guys do will be a review. Now, there is one thing. I would like to give you a quiz, one more quiz. And if I give you this quiz next week, I will drop the lowest 2. Okay, because according to my syllabus, I am done with quizzes, but I don't mind giving you one extra quiz, and I will give it to you, but then I will drop the lowest 2 quizzes. So it'll give you like extra time to do that. Now, would you like your quiz on Thursday or Tuesday? I will pick if you guys don't vote.
Tuesday, maybe.
Tuesday. Anybody else? Tuesday. Okay, Tuesday is winning. So your quiz will be on Tuesday. All right. Since that's I don't really matter. So the Tuesday will be the quiz. And I would like to have a quiz because I want to really make sure that you guys are doing the homework. And if you do mistakes, I can address them on Thursday because this stuff will be very much, big part of your final. All right. Any question before I let you guys go?